The symbols and input-output characteristics is very important. Input-output characteristics. Also, two important characteristics of an op-amp. Last class, I think we took long time in explaining the two characteristics. One is it has very high input impedance and very low output impedance. The other is it has infinite gain and bandwidth. Okay, it's very easy to say, but this is the ideal expectation from an amplifier, and it satisfies all. This is a schematic analogy of an operation amplifier. This we have already discussed in the previous class, where we have a transistor-based amplifier. We should be able to, make all this, realize all this in an IC technology. All we need is we need a provision for input, we need a provision for output, we need a provision for giving the power supply, external power supply to that. So we said we call that as input port, output port, and power port. Of course, to adjust the gain, any of these resistors we need to view outside. We will connect it outside so that the gain can be adjusted from outside the IC. So that we made an abstraction, and this we call it as an operational amplifier. This is input port, output port, and power. In power port, we will connect plus VCC and minus VCC. In our normal transistor base, normally we connect only positive VCC. Here we connect both. Right. The first device that we are going to see using operational amplifier is inverting amplifier. Okay. Last class, when we discussed about the basic symbol, I told this is an inverting end. This is non-inverting input. That is inverting input, non-inverting input. And then this is the amplifier that what goes inside we already said. So you have an input voltage that needs to be amplified, and you give this input to an inverting terminal and take the feedback, connect it to feedback resistance, connect it to this input. Then this circuit will act as an inverting amplifier. Of course, non-inverting amplifier you have to connect it to ground. If you don't connect it, it won't work. It is in the floating condition, it won't work. It has to be in ground position. This has to be connected to ground. For inverting input, you connect the input through a resistor. You will understand what is the need for that resistor. And output, you take a feedback through the feedback resistance. You connect it to, again, along with the input you connect. Okay. So this will act in a loop such that some things are satisfied. To understand the working of operational amplifier, we should also learn golden rules of operational amplifiers. What is that golden rules? The first rule says no current flows through input terminal. Okay. We already learned this in another form. Operational amplifiers have very high input impedance. Very high input impedance. That means what? If I put lot of impedance, resistance to the flowing of current, will any current flow inside? No. So no current flows through the input terminal. Both input terminals. Okay. That's the first rule. And the second rule, no voltage difference between operational amplifier input terminals. That means voltage at the inverting terminal equal to voltage at non-inverting terminal. Voltage at inverting terminal is equal to voltage at non-inverting terminal. These two are golden rules of operational amplifiers. So this the thumb rules you should know. Now, if you are going to make use of this, this is like a fundamental law, like a Newton's law for mechanics. So we apply this law, and then from there we derive energy equation, that equation, this equation, equations of motion, Bernoulli's equation. All that comes from all those fundamental laws. For operation amplifier, these are all the thumb rules based on which we are going to derive. Okay. So now, of course, we have a physical reasoning as well. Because input impedance is very high, no current flows through that. It's understandable, isn't it? Yes or no? Okay, fine. No current flows through this. Anyway, it is connected to ground. There is no current going to flow. Whereas here we have connected Vin to this inverting terminal, and here at A, what are all the currents that are coming to that particular node A? call this point node as A, what are all the currents that is coming? This is R1, so the current flowing through that I call it as I1. This is the feedback resistor, so the current that is coming back I call it as IF. That is RF, this is IF. IF representing feedback current. Okay. So some current is coming through this. Will there be any current at the output side? Input, I am not, device is not taking much current. Ideally, there will be no current, but practically there will be some current. But ideally, there is no current that is flowing in. But how about output? Output? No impedance. Low, very low impedance. That means any amount of current you can draw. From power supply, that those current will come, external power. Okay. So this current is possible. So this current is coming. That is IF. That's a feedback current. This is the input current that's coming inside I1. And both are coming here. And anything that can go inside the op amp, no, nothing will come. So I1 plus IF should be equal to 0, because there is no way that the current can flow that side. So current that is flowing at that junction has to be 0. Then only no current will flow inside the op amp. If it is not 0, I1 is not equal to IF, or I1 plus I2 is not equal to 0, then there is some resultant current that somewhere it has to flow. Somewhere it has to flow. There are only 3 ways. One way I1 is coming, one way IF is coming. There is only one way, and third way only the current can go out, isn't it? It cannot go reverse. If it is going reverse, that will affect I1 and then it get adjusted. So we said some I1 is coming, some IF is coming. The third way, if it is a non-zero value, okay, then this can be different. Now, here we said it is 0, no current can flow through that. The way is blocked, no one can go through that. So that means my I1 plus IF equal to 0. I1 plus IF equal to 0. That is the very fundamental equation. After that, it is all just blah blah. You understand that first equation that we wrote? I1 plus IF equal to 0. Anybody who do not understand that? It's clear, right? Clear. Right, okay. Now, all of us know V is equal to IR. What is that? Voltage is equal to current times resistor. What is this? Ohm's law. So I is equal to V by R. Isn't it? I just bring this down. So I1 here, what are the resistance and voltage connected to that? R1 is the resistance responsible for this I1, and V1 is the voltage that is responsible for that I1. Isn't it? Yes or no? Right? So the I1 I am replacing with V in divided by R1. Is it alright? V in divided by R1. Alright. Similarly, what is the resistor and voltage that is responsible for this current, or what are the resistor and voltage associated with the IF? It is V out divided by R. So I substitute V out divided by R. Plus sign I read it equal to 0. This equation and this equation are same. I have rewritten using Ohm's law, using other parameters. Is it clear to all of you? Now, I am interested in, I know what is my input value, voltage that I have. I am only interested in what is my output value. What is my output value? So, therefore, V out, output voltage is equal to, you bring that side, it becomes minus V in by R1. You take this RF upside, it becomes minus RF divided by R1 into V in. Okay. V out, the output voltage is some factor which is a ratio of two resistances times V in. V in is multiplied by the resistance ratio. The resistance ratio. If that ratio I can manipulate using resistors, I can manipulate the input voltage. For instance, if I put here also 1K resistor, 1 kilo ohm. Normally they say 1K, they don't say 1 kilo ohm because it is commonly understood as kilo ohm only. Okay. 1K resistor means 1 kilo ohm resistor, not 1 kilogram. Okay, naturally resistor is ohms. So they used to tell 1K resistor. But when you write in the exam, don't write 1K, 1 kilo ohm you have to write, then only it is the right answer. But while talking, we use 1K resistor, 2K resistor, like that. So you put 1K resistor here, 1K resistor here. Then 1 divided by 1, it becomes 1. Then what will be the output voltage? Output voltage will be same as input voltage. Okay, output voltage is same as input voltage. Okay. Suppose I put RF is 2K, 2 kilo ohm, R1 1K, 2 divided by 1 times input voltage. So if I give 2 volts here, what will be the output? 4 volts will be the output. Why? The gain is 2 volts there. Okay. This ratio RF divided by R1, we call it as gain. RF divided by R1, we call it as gain. Okay. And the input voltage is multiplied by the gain to get the output. It can also, if the gain is more than 1, you call this device as an amplifier. If the gain is more than 1, you call that device as an amplifier. Why? Whatever the input I am giving, the amplitude is enlarged, so I call that as an amplifier. Amplified, so I call it an amplifier. If the ratio or the gain is less than 1, is it possible to have less than 1? Naturally. I put 2K here, 1K there. Then it is 1 divided by 2 of this thing. If I give 10 volts as input, I'll get 5 volts as output. Voltage got reduced from 10 to 5. If the gain is less than 1, I call this device as an attenuator. What is that? Attenuator. Attenuator is, signal attenuator, you might have heard, right? Attenuating means grounding. It is reducing the power. Okay. So, amplifier, if it is greater than 1, gain is greater than 1. Attenuator, if the gain is less than 1. What if the gain is equal to 1? If the gain is equal to 1, it simply follows the input voltage. The output voltage simply follows output voltage. There is no amplification, there is no attenuation. So simply follows. So such devices, we have many names. One is voltage follower. Whatever is the input voltage, output voltage follows, so it is voltage follower. The other name is buffer. Also it is called unit gain amplifier. It doesn't have a much gain, but unit gain amplifier. Like that, you have various names if the device gain equal to 1. Okay. So this voltage, this expression is the fundamental expression that you should know in operation amplifier. All our discussion is going to be based on this. Very, very, very foundation to for the entire class, probably next class too. So this output voltage is gain times input as the equation for amplifier itself. We said it is an inverting amplifier. So what does that mean? Inverting amplifier. If I give 1 volt, if the gain is 5, what will be the output voltage? Minus 5 volt. If my input is minus 2 volts, gain is 5, what will be the output voltage? Plus 10 volts. Not only it is getting amplified, but the sign of the signal is changed. It is inverted. If it is positive, change it to negative. If it is negative, change to positive. So it is called inverting amplifier. When you connect the input to inverting end, you get inverting output. The input is inverted and you get an output, so it is called inverting amplifier. And this minus sign signifies that. I think I have explained all that. Is it clear to all of you? Any doubts? Anything? Okay? No. So if you know this, the similar work, you take any LIC book, this is non-inverting amplifier. Similar expression we can draw. Same Ohm's law, same thing you write. Simplify, you get this equation. What is that? You connect the input to the voltage to be amplified, you give it to non-inverting input, and the inverting input you connect it to ground, and this is RF, this is I, and sort of like this. This circuit configuration is non-inverting amplifier. Is non-inverting amplifier. Here the expression for output voltage is given by this. It is R2. Okay, there is a printing mistake because that's made by me. This is R2. Okay, or here you change it to R1. Anyone change your because that refers to the feedback resistance. It is 1 plus R2 divided by R1 into V. So the inverting amplifier can act as amplifier, voltage follower, and attenuator. Whereas this device can never act as attenuator. This device can never act as attenuator. Whatever the different combinations of R1 and R2 values that you put, even you put 0, at least you will get whatever input you give, you will get as output. So those devices are called, not called, but the speciality of this device is this. It will never act as an attenuator. At least input will be given to the output, or it is amplified and given. It is never, the amplitude is never reduced. The power level of the signal is never reduced. Such a device is the characteristics of this non-inverting amplifier. Okay, except this one idea, non-inverting and inverting same. There is no difference at all. Okay. Up to this is okay for all of you. Here comes the full circuit. You have differential amplifier. You have differential amplifier. We also learned the important characteristics of an amplifier. What is that? The amplifier amplifies the difference between two inputs. I think last class I might have stressed upon that point. Look at here. You have R2, that's feedback resistance. You have R1 that you have connected to both input 1 and input 2. You have two inputs. You want to amplify the difference between the input. You want to amplify the difference between the inputs. That device is a differential amplifier. So V1, so V2 minus V1, because this is positive V2, this is minus V1. So it is V2 minus V1 is amplified and given as output. Number 1. What is the expression here? Feedback resistance divided by input resistance. Input resistance should be same. Then you can use this formula. Otherwise, you wait. Next slide we have answer for that. Okay. So the V2 minus V1 you take, and the feedback resistance divided by input resistance is the gain. R2 divided by R1 times the differential voltage will be the output. Okay. You want to now, put this 0. That means there is no current here. This is not connected at all. As soon as it is not there, so this is connected to ground. You get inverting amplifier. You get inverting amplifier. Similarly, you don't connect V2, connect only V1, you will get non-inverting amplifier. So this is the masterpiece of the operational amplifier. So differential. This I already explained. This is buffer, voltage follower, unit gain amplifier. It is just an operational amplifier, simple. The idea is the input voltage is equal to output voltage. There is no gain on that. What is the use if I am giving one input signal? If I am taking the same output signal, why should I do that? Hey, there is a Tamil movie and there is a joke. Tamil people will be able to enjoy. There is a movie dialogue that comes. The meaning of that, after taking 6 pecks of whiskey or vodka or some liquor, you don't get the kick. Why the hell you should drink that? You don't have to drink, isn't it? Not wasting time and money and health, not needed. You get some input, give some input signal, you get the same output signal. Why are you using that device? It is like this. You come to the class, 50 minutes you attend the class, you go with the same knowledge, you don't get any extra knowledge. Why should you come to the class? If you ask that question, you don't come to my class at all from tomorrow. That's a different question. But anyway, for an academic discussion sake, we will ask. If, see, I don't want to come in. If input is equal to output, why should we use the buffer at all? Any response? Why we should use? What is the important characteristics of an amplifier? Huh? Power level is not increased, same power level. If I give if I give 2 volts inside as input, I get 2 volt output. Huh? No, if you directly keep it, the signal is not distorted at all. Then why do you need a device there? Any guess? What is the important characteristics of an operational amplifier? Yesterday we discussed, today we reflected. Important characteristics of an amplifier. Yeah, no current flows through the internal terminal. Why? Because there is a huge resistance, high impedance, input impedance, high input impedance, isn't it? If no current flows through this high input impedance, no current will be drawn from them. No current will be drawn from the source. But if I am connecting this voltage signal directly to the display unit or directly to the measuring unit, the measuring unit or display unit may draw some amount of current. This signal will die in the process. If the signal is feeble, weak signal, the signal will die. It will not be able to supply current. Okay, you will get sometimes zero output. There will be some voltage, there will be some current, but if devices start swallowing some amount of current, the signal will die. You will not be able to measure it. Whereas, if I connect a voltage follower, this fellow is a perfect gentleman. It won't draw any current because of high input impedance. It doesn't accept any current. But this fellow can give any amount of current. This fellow can give any amount of current. Voltage is not changed. Voltage is not changed. If at all you want the extra current that comes out of it, so as I said, the same voltage, the power level is slightly increased because of the current that is being supplied from the external power source. Voltage will remain same. So voltage alone, when you look at it, this is 5 volt means this also will be 5 volt. But this cannot give the current that is demanded by the next block of circuits in the entire circuit. But this will be able to supply the necessary current because that has external power supply. Current source may be there. It will be able to supply any amount of. The amount of current is a very vague term, but whatever is needed by the other circuit component, that will be able to provide. So voltage follower is used wherever the signal is very weak, very weak. For example, we have learned piezoelectric accelerometer. You remember piezoelectric principle? What is that? If you have a crystal, piezoelectric crystal, if you apply force on 2 parallel sides of it, the charges are developed in other 2 parallel sides. It is only charges. It is not even voltage. Some positive charge on one side and some negative charge on the other side. So the charges, if charges are more, that you call it as potential difference, and there will be a current flow. Even charges there will be current flow, but current will be in microvolts or 0.001 microvolts, something like that. Very feeble signal. That you have to take, amplify it, and then calibrate it in terms of vibration. Piezoelectric based, any sensor. Piezoelectric doesn't give 3 volts, 5 volts output. It gives only microvolts. Basically, the charges that are produced because of the vibration. So, for such signals, if you want to amplify, you use an instrumentation amplifier. You use an instrumentation amplifier. The building block of instrumentation amplifier is 2 items. One is buffer, other one is differential amplifier. So you take an instrumentation, you take a differential amplifier. The first input you send it through a buffer. The second input you send it through another buffer. So this is V1 is one input, V2 is another input. First it is sent through an amplifier, then it is sent to the main differential amplifier, and you get better amplification. You get better amplification. You can ask one question, sir, this is also an amplification amplifier, that also will not draw current, directly you can connect. No. Why you want a buffer there? Additional protection, additional gain. The signal is amplified much better if you have a buffer in one stage. Okay? Especially this instrument, this circuit component, the instrumentation amplifier, comes handy when the signal is very weak, like signals coming from piezoelectric crystals or very low signal producing signals, anything for that matter. There are many voltage signals that are very small. Even you have strain gauges, you connect the Wheatstone bridge. The amount of voltage difference for a given strain is very small. If you want to amplify that to a greater extent, then you need to connect this kind of instrumentation amplifiers so that the gain is more without loading the physical parameter. Since this amplifier is very frequently used in measurements instrumentation domain, this name of the amplifier is instrumentation amplifier. Whereas other amplifiers are used for audio purposes, audio amplifiers, using a huge sound is manufactured because there is an amplification of the audio signal into a bigger signal, and that's given to the speaker, it makes a noise. So that had many applications, but this very frequently used in instrumentation domain. That's why people have named this amplifier as instrumentation amplifier. Summing amplifier. Okay, up to this is clear? Any questions? Any questions? Summing amplifier. This is the question that I'm going to ask in the exam. It is open book test. Question is also out. But let me see how many of you score. Question is out. Open book exam. That means I already told you the question. This is the question I'm going to ask. Raise, if you are able to convert the raise into a signal, voltage signal or current signal, you will be able to do it. For example, you have a photoelectric cell. You have sun rays coming. If that rays you allow on the sensor, the photoelectric sensor will convert the light intensity into proportional voltage signal. Proportional to the light intensity, the voltage will be there, but that voltage will be very small. If you want to amplify that, you can use the amplifier. Directly rays cannot be captured because rays is not a signal which can be handled by electronic devices. Electronic devices understand only voltage or current. You need a sensor. Ray is a physical entity. That ray physical phenomena has to be converted into an electrical signal. Then this instrumentation, signal processing is possible. As a physical parameter, we cannot. E? Yeah. If you have a device which will respond to that particular physical phenomena, you can do it. Okay. go to summing amplifier. This is summing amplifier. What is meant by summing amplifier? I have only one input. I take only inverting amplifier. That is the important building block, as I told earlier. This is an inverting amplifier. To this, I have not connected only V1. Earlier, I have through R1, I have connected only V1. Now I have two inputs. Both inputs I have simply connected there only. Through R1, I have connected V1. Through R2, I have connected V2. See, V1 I have connected through R1. Same inverting input. V2 also I have connected to same inverting input through R2, resistance 2. Alright? My equation, you can derive from first principles again, but my equation says always the output voltage is feedback resistance divided by that corresponding input resistance into that particular input voltage. So feedback resistance divided by that corresponding resistance into that corresponding voltage. That is the component amplification because of V1 plus feedback voltage divided by input resistance voltage into that voltage V2. This much output is because of V2. Sum both you get total output. So RF divided by R1 into V1 plus RF divided by R2 into V2. If you have these two quantities, you get your output. This equation is going to help you to fetch 25 marks in CAT 2 and probably 10-20 marks in the double exam. Just one equation. What is that? V out is equal to, of course, minus of RF divided by R1 into V1. Alan, 25 marks in CAT 2. You cannot afford to be gloomy, afford to sleep. It will evaporate. You will miss the bus then. CAT only ever market. CAT 2, go in the. Yeah, because I am challenging you. I told you the question also. I told you it is open book test. Then you should see how tough the question will be, isn't it? And if you don't understand, you cannot touch the question paper. You take the question paper, you give the answer book, and then say thank you, sir, to the invigilator, and then come. Listen carefully, okay? The more and more inputs you get about the question, the more and more naturally it will be tough to attend, isn't it? So you should be prepared for that. So output voltage is equal to this. This equation, any doubt? This equation. Same thing. Whatever we have derived, I will tell you. See, any doubt, you go back to inverting amplifier. This is the equation for output voltage. What is this? It says input voltage. What is the feedback resistance divided by what is the resistance associated with that particular input voltage. That will be the output voltage. If I have two input voltages to the same point, not different point. If it is different point, that is different equation. Here V1, here V2, that difference will come. Same input, that is the inverting input. What is the formula? The feedback resistance divided by input resistance into that particular input voltage. That is the amplified voltage because of V1. Feedback resistance divided by R2 multiplied by V2 will be so much voltage because of V2. V1 amplified plus V2 amplified will be total amplified. That's the expression. Negative sign is anyway there, it is common for both the components because it is inverting amplifier. Alright? So this is going to play a big role. Now, how to, why it is called a summing amplifier? I am going to put all resistance 1K. RF 1K, R1 1K, R2 1K. All 1K, 1K, 1K. What happens? Of course, minus sign stays outside. 1K, 1K cancels off. 1K, 1K cancels off. Now what remains here is V1, what remains here is V2. Hereafter it is only mathematics, no electronics. So anyone can follow. Okay, don't research all electronics above the head. It's all simple mathematics. So I put 1, 1, 1, 1. What remains here is V1 plus V2. So the device reduced to now summing amplifier. If I give 2 volts in V1, 3 volts in V2, what will be the output? Minus 5 volts. Just ignore the minus sign. 2 plus 3, 5. Whatever the voltage I am giving, I am getting summed up and giving an amplifier. So I have an adder circuit. Any two number I give as input, that is getting added and I am getting as output. This is an addition operation. How to make this as to do an average operation? I have V1, I have V2. 2 volts input 1, 3 volts input 2. I want average of this in the output. How to get average output? You have to simply manipulate the resistance ratios. How do I manipulate? Huh? R1, 2K. You put 2K to R1 and R2. RF will remain 1K. Beautiful. So this remain 1K. This I make it 2K. This I make 2K. It is 1 by 2 V1, 1 by 2 V2. So V1 plus V2 divided by 2. So it becomes an averaging circuit. Where will I use averaging? Suppose I have a pipe through which some hot fluid is going. The temperature of outer layer and temperature of inner layer need not be same. Mostly it will not be same. Why? Outer side is exposed to the atmospheric temperature. So there is, due to convection and radiation, of course through convection also, all modes of heat transfer takes place. So heat will be, temperature will be slightly less at the outer surfaces. Slightly. In the inner core, the temperature will be slightly more. Isn't it? In a pipe, hot liquid flowing through a pipe. I want the average temperature. So I put one thermocouple in the middle, other thermocouple towards eccentric, not in the middle but slightly offset distance, but inside the pipe. I want the average temperature. So what will I do? Whatever the voltage that is coming, I connect it to V1. Whatever is the second signal that is coming, I connect it to V2. Then the output will be average of. Of course, the minus sign will be there. That you can negate or ignore it. You can do signal processing, so I know that minus sign is taken care of. But the amplitude is average, and then so I get the average output from this. Is it fine? Okay. Okay. We'll stop here. And next class then it is more important because I just started the